To determine if a frame is stable, we can cut it at some point and expose the internal forces in each part of the frame. So from left to right, we use this convention, where the tensile axial force is positive, and on this side, we use the left-hand positive convention. So here we have two parts with 3 equilibrium equations per part. So that gives us 6 equilibrium equations. And here we have 3 unknown reactions plus 3 unknown internal forces, because these forces and moments here are equal and opposite to these. So therefore we have 6 unknowns. And because the number of unknowns is equal to the number of equations that we have to solve for them, then this frame is stable. And as we did with trusses, if this were a roller, then we'd have less unknowns than the number of equations to solve for them, and therefore the system in this case is overdetermined. And you can see the frame is unstable, because if we were to apply a load to it here, it'll just roll forever. And similar to trusses, if we had this roller oriented as follows, and we had another roller over here, well, the lines of action in this case are going to pass through a common point. So therefore, if we take a sum of moments about this point, then we can see that the externally applied load is going to cause the frame to rotate about this point. And because the reactions pass through that point, they're not going to provide any rotational resistance. And therefore this is another case where the frame is unstable, where we have the same number of unknowns as the number of equilibrium equations to solve for them.